So now that we know the 5 different types of chemical reactions, we're going to start to learn about predicting chemical reactions. Now, just because we put things together doesn't necessarily mean that they are going to react. So in this video, we're going to begin to learn about how to understand whether or not something is going to react or not. So starting with the first of our 5 types, we have the combination reactions. So for combination reactions, that's when we put 2 elements together and they form a compound. So some examples are that are a little bit more complex than that are like this example here, and these are given to you in your reference tables. It's taking a non-metal oxide and reacting it with water to form an acid. So this is a non-metal oxide here. Sulfur is a non-metal and it's with oxygen, and if you put it with water it forms sulfuric acid. But just by looking at this, you can see that it's a combination because you have 2 things on the left and 1 thing on the right. Now, it gives us this description in your reference table, but you might not necessarily need to predict this product, but I just want you to recognize that there are some cases of combination reactions that aren't just simple element to compound. Here's another example. So if you have metallic oxides, these react with water to form a base. And in a few units, we're going to be talking about acids versus bases, which is why I wanted to sort of mention these reactions here. So here you see a metallic oxide. Calcium is a metal with oxygen reacting with water to form calcium hydroxide. A base is anything that has a hydroxide on it, and we know that an acid is anything that starts with an H. So those are just 2 other examples of combination reactions. Okay. Other than that, we're just going to simply have the idea of putting 2 elements together to form their compound, which is very easy to predict, and I will always give you reactions that actually occur. Now for decomposition reactions, again, we're going to have 1 compound breaking down to form its elements. So in these cases, again, I will always give you something that's actually going to happen. You won't have to predict whether or not the reaction is going to happen. So you would just take the compound, break it down into its parts, and really the only thing that you've got to remember is that we have the diatomic molecules, the Mr. Brinkelhoffs, so if they're ever alone, that they are in a pair, and again, you can see this is an unbalanced. Now, there are some other more complicated ones on the reference tables. However, really, you just need to be able to recognize a decomposition by its form, and I won't ask you to do very complicated decomposition reaction predictions on the test. Alright, so let's look at some single replacement reactions. So this is where it comes into play, where now we're going to have to decide whether or not the reaction actually occurs. Not always when you put an element with a compound does a single replacement occur. So remember that a single replacement is when 1 element replaces another from a compound. So your reactants are an element and a compound, and your products are an element and a compound. So here we have sodium, and then the compound potassium chloride. Sodium kicks potassium out of its compound to form potassium and sodium chloride. So this is an example of a cation switch. We also can have an anion switch, and this would happen if we're started with an element here, fluorine, that's a nonmetal, reacting with lithium chloride. Fluorine is a nonmetal, so it's going to kick the nonmetal out of the compound, so this is a nonmetallic single replacement. And so we end up with lithium fluoride and chlorine. So this is an anion switch. So we can tell whether or not the reaction happens, and this is by using something called the activity series. Some chemicals and elements are considered to be more active than others, and if you're a more active element, you are going to replace a less active element from the compound. So we have something called the activity series of metals, and it's listed in order where you have on the higher up on the list, the more active you are, and the lower on the list, the less active you are. So this is the activity series of metals. There is a copy of this in your reference tables, and we'll use it in a second in order for me to demonstrate a few problems. So up here you have things that are very active, and down here you have things that are less active. Hydrogen is included in this list even though it's not a metal, because a lot of times hydrogen is involved in single replacement reactions. So metals can replace other metals provided that they are more active or higher on the list. So for this example, zinc could replace lead because it's higher up on the list, but lead could not replace zinc from a compound. Now, included in this list, like I said, is hydrogen because we're going to be dealing with a lot of acids, and we sort of treat hydrogen like a metal when it's in the acids. Okay? And, don't worry about this. We'll just leave it at that for now. Okay. Now we also have the activity series of halogens. So this is the activity series that we use when we're trying to determine if a non-metallic replacement would happen. So again, it works just like the activity series of metals. The higher you up are on the list, the more active you are. The lower you are, the less active. So if you're a single element, you would replace one of the lower ones from the compound. Right? Now let's just do a couple of examples. And actually I'm going to hop to the Elmo for this one so I can demonstrate it using your reference table. Alright, so here you can see on your reference table, this is on the same page where the polyatomics are, that we have the activity series of metals and the activity series of halogens. Sorry, I just turned the light on so you can see this a little bit better. So the activity series of halogens is here, and that's separate from the activity series of metals that's here. But again, if you're higher up on the list, you're more active. So if we're going to predict the products and whether or not a reaction would happen, let's use a couple of these examples. Now this is a worksheet that I got off the internet, and actually I'm going to post it on the Moodle, and it has an answer key with it. So if you feel like you need more practice other than the ones that I provide for you in class, you can go ahead and do these ones. Okay, so I'm just going to do the circled problems. So we're going to start by looking at the elements and the compounds, the reactants here. We've got iron and aluminum oxide, and I'm just going to write the formulas. So iron's just Fe, and then aluminum oxide, remember aluminum's a +3 and oxygen's a -2, so we're going to have Al2O3. So my next step then is to see, will this reaction actually happen? Will a single replacement reaction happen here? And in order for it to happen, that means iron has to be more active than aluminum to steal oxygen away. So if I look at my list, I see that aluminum is right here, and then I see that iron is right here. So iron is lower on the list than aluminum is. So in this example, we're going to say NR, no reaction. This reaction is not going to occur because iron cannot replace aluminum from that compound. All right, let's do another one. So we've got sodium, bromide, and iodine. So sodium is Na, and remember it's a +1, and bromide's a -1, so it's going to be NaBr plus iodine. Iodine's a Brinkelhoff, so it's going to be I2. So in this case, my single element is a nonmetal, so I'm going to have to use the nonmetal or the halogen activity series of halogens and see whether or not this reaction is going to occur. So here I've got sodium bromide, so iodine wants to replace the bromide, but iodine is lower on the list than bromine is, so again, this is going to be an example where we have no reaction. All right, let's look at number 7. So number 7 is calcium, so that's just Ca, and hydrochloric acid, so that's HCl. So in this case, we're going to be using our activity series of metals because we have a metal here. So if we look on the list, we see calcium is right here, and hydrogen is way down here. So calcium is higher than hydrogen, so we know this reaction is going to happen. So now that we know the reaction is going to happen, let's go ahead and write our products. We know that calcium is going to kick hydrogen out of the compound and steal chlorine away. So when I write my products, I need to use my formula writing rules, okay? So if hydrogen gets kicked out and is by itself, it's going to be H2 because it's a Brinkelhoff. It comes in pairs when it's by itself. Now, calcium then is going to steal chlorine away. Now, remember that calcium is a +2 and chlorine is a -1, so when I write the formula, I need to write CaCl2. This is the most common error when we're predicting products is people forget to write their formula, use their formula writing rules, and they just sort of swap letters around. So make sure that you're thinking about that when you're writing your products. Then we go back and we actually balance in order to make this thing a balanced chemical equation. So I'd put a 2 there. Okay. All right, let's go ahead and do another one. So here we have silver and sulfuric acid. So you've got silver is Ag plus sulfuric acid is H2SO4. So I've got to look and see, is silver higher than hydrogen? So I look over here and see silver's way down here, hydrogen's higher on the list. So this is going to be another example where no reaction occurs. Okay, let me do one more. Let me do number 5. Okay, so in number 5, we have aluminum bromide. So that would be Al, which has a +3. Bromine has a -1, so it'd be AlBr3, plus chlorine, which is a Brinkelhoff. Chlorine's a nonmetal, so in this case I'm going to use the activity series of halogens. And I see chlorine is higher up on the list than bromine. So this reaction is going to happen. Chlorine's going to kick bromine out of the compound. So let's go ahead and write my products. So bromine's going to be kicked out all by himself. And it's a Brinkelhoff, so I have to write Br2. And then aluminum's going to steal chlorine away. Chlorine also has a charge of -1, so it's going to be AlCl3. And then I have to go ahead and balance my equation here. So I've got 3 bromines and 2, so I'm going to need to make it so that there's 6. So I'm going to do this, and then I need 2 aluminums over here, and then I'll need 3 chlorines here. Okay, so these are examples of using the activity series in order to determine whether or not a reaction will occur for a single replacement, and then writing the actual products and balancing a single replacement reaction.